A mirage, you say, Dick Weatherman. A mirage? Seeing the Chicago skyline from across Lake Michigan on the Michigan shoreline, 60 miles away. A mirage? Dick Weatherman?
This from the Lake Michigan shore. We talked about this last night. Conditions are right on the lake. We're actually seeing a mirage of the Chicago skyline. Very interesting here. Here's what's happening. This is a good example of a superior mirage. So Joshua was on the Lake Michigan shore. He was looking towards the west, and Chicago's beyond the horizon. Should not be able to see it. However, with the right conditions, we have an inversion. We have cold air near the cold lake water and some relatively warmer air above it. This will bend the image.
If it was an inversion like a normal superior mirage, the skyline would be upside down, wouldn't it? Wouldn't it? I talked about it earlier with a horizontal crease because there's a glass sky, but seeing the Chicago skyline from that far away has to do with the fact that light is bending and it varies in its curvature from different times of the day depending on the conditions. Okay, a little graphic at the top left here shows you the difference between if light were straight at the bottom on a convex ball and there's a cutoff, how they normally describe why a ship disappears at a distant horizon. The hull disappears, but light has been proven to bend with experimentation. You're in the concave ball earth, and what's going on is light is bending like that and it's clipping it. See the top part of that illustration there? That is what's really going on, but at certain conditions, whether it has to do with temperature or sunlight or time of day, the amount of curvature will vary. And so sometimes when the conditions are right, we're able to see a very long distance. They call this looming. Looming. Okay, it's not flat. Already busted flat earth theory. Stuck a nail in its coffin, in its flat coffin. It's done with. The only logical alternative is concave spherical earth. And so that's what's going on here. And that's why things get clipped in the distant horizons. Because light is bending. You still have this blind spot beyond the boat, below the blue line there. Alright.
Yeah, I've been doing some tinkering with line of sight, basically. And, here again.
Mic check. 1, 2, mic check.
Here again.
I'm using my, what I'm going to do, I'm just using my Bluetooth headset. I'm going to go lay out in the grass.
What I was doing here, just clean this up a little bit here. This is a process of figuring things out, but this blue area is Lake Michigan, and this black line is the Sears Tower, or the Willis Tower. And this point is the point in Michigan where Josh Norwicki filmed the Chicago skyline. And I got two line of sights, two sight lines here. We got the red line, and we got this purple line. Under normal conditions, we're going to see things with the red line, so the light is bending up more. So if we start all the way over here on this side, you're going to create the horizon in the middle of Lake Michigan, and then it's going to rise up. And it's going to pretty much eclipse, you'll barely see maybe the antennas, if anything, of the Sears Tower. But like under that condition, when he filmed it, we had the warmer air being actually above the colder air, so it was actually causing the light to refract more, or to rise up at a slower rate, and so it bent it down more, so he was able to see, a good, like half of the building basically. So that's what's happening, but it's continually bending up. So when you're able to see longer distances, it's just bending up less than normal conditions. And also too, like I have these line of clouds here. They're about, like, each one of these green vertical lines or these green horizontal lines is 5 kilometers. So if you have this cloud ceiling at like 5 kilometers, if you're standing over here where Josh was standing, you're gonna. That's the reason why the clouds in the distance have a perspective to them. You know, you're gonna see this this blue curved line would be your squished sky dome. So like objects that are not as high as the moon or the sun, you're gonna have a truncated sky dome. But the celestial objects obviously they get higher, like the sun and moon. You're gonna have a more curved sky dome, basically.
Mhm.
So if you have like grazing meteors or meteor showers that's all they're doing. They're just skidding across the glass sky 100 kilometers high. So you're gonna have more of an arc. You know, you're gonna have this arc over here, approximately. But that's what's going on, I think.